Hello everyone, welcome to StudyZone. Today let us see about logical equivalences. Two compound propositions, that is P and Q, are said to be logically equivalent if P biconditional Q is tautology. So the symbols used to represent logical equivalences are these two. So these two represent the logical equivalences. So there are some basic logical equivalences, which means laws. So you must understand to solve the logical equivalence problem. So let us go through the laws one by one. And the first law is identity laws. In identity laws, P and true is logically equivalent to P and P or false is logically equivalent to P, which means here 0 into 1 will give 0, right, which means P value, and then 1 into 1 is also equal to 1. Here the answer will be the P value. So identity laws say that P and true is logically equivalent to P, and then P or false is logically equivalent to P. And then domination law. In domination law, P or true is logically equivalent to true, correct? So P means 1, or which means 1 plus 1, which is equal to 1. So true, true, same. And then 0 plus 1, which is also equal to 1. So here also they are same. So here there will be domination of true. So then it is called as domination laws. And then idempotent law. Idempotent law says that P or P is logically equivalent to P. Correct, right? 1 plus 1, which is logically equivalent to 1. And then P and P is logically equivalent to P. And then double negation. Single negation means not P. Double negation means negation of negation P. So negation of negation P means negation cancels. What will happen? P. And then commutative laws. You have seen the examples of A plus B equal to B plus A. Same thing, P or Q is logically equivalent to Q or P. And then associative law. It's also you have seen before. What's that? A plus B plus C equal to A plus B plus C. Correct? So same like this, P or Q or R is logically equivalent to P or Q or R. And then distributive law. This one also you have seen before. A plus B into C is equal to A plus B into A plus C. Correct? So P or Q and R is logically equivalent to P or Q and P or R. And the most important one is De Morgan's law. Here negation of P and Q, when you try to expand it, it will become negation of P or negation of Q. Here the symbol changes. In De Morgan's law, if you want to expand, the symbol changes. And negation of P or Q will become negation of P and negation of Q. So these are the basic laws that is useful in logical equivalence. So let us go through some of the examples. So let us take these two examples and try to solve the logical equivalences. So here there is P implies Q is logically equivalent to not P or Q. So let us take P as true and Q as false. So true implies false is logically equivalent to negation of P is false and Q same, it is false. So false or false. T implies F. What we have to take? We have to take the last symbol, correct? So false is logically equivalent to false. So because 0 plus 0 is 0. So these two statements are logically equivalent. So let us go through the second exercise problem. That is, take same like the before example, true, false. So negation of false is true and negation of true is false. True implies false. which means we have to consider the last symbol, that is false, and then not Q implies not P. So T implies F. Here it is logically equivalent to, here also we have to consider the last symbol false. So here both the compound propositions are equal. Like this, logical equivalents are used. So we have seen about the important laws in the logical equivalence and 2 examples in logical equivalence. In the next video, let us solve the problems under the logical equivalence. I have taken 2 examples to solve the logical equivalences. So in the first example, there is P implies Q is logically equivalent to not P or Q. Here take P as true and Q as false. Negation of P is false, and here Q is same, so it will become false. Therefore, let us start solving. P implies Q, which is logically equivalent to not P or Q. P means true and Q means false. We have to check whether they are logically equivalent. Not P means false or Q, that is also false. In T implies false, we have to look after the last value, that is false. Therefore, the answer will be false. Here we have to check whether it is also false or not. Here 0 plus 0 is 0, which means false. So they both are logically equivalent. So let us go through the second examples and check. So here P implies Q is logically equivalent to not Q implies not P. So P means true, Q means false, and we have to check whether they are logically equivalent to not Q. Not Q means true, which implies not P, that is false. So here true implies false is logically equivalent to true implies false, because true implies false is false and true implies false is again false. They both are logically equivalent. Here it is a simple example. In the next video we will go through some of the problems where we will solve with the help of De Morgan's law, distributive law and identity law, all that. So for today, thank you.